Okay, good morning, everyone. Thank you for attending. Uh, my name is Mackenzie Woodman, and I'm the Geology and Remote Sensing Application Specialist here at Spectral Evolution. And today I'm going to discuss the newest innovation here and introduce to you the Naturaspec Plus, our newest spectroradiometer. So to start, I'll introduce Spectral Evolution to any new attendees. Spectral Evolution is the leading manufacturer of field-based UV-Vis NAR spectrometers and spectroradiometers. We were established in 2004, so we have about 21 years of experience here, and we're located in the Boston area in Haverhill, Massachusetts. So Spectral Evolution's instruments are primarily used in the fields of hyperspectral applications, remote sensing and vegetation, mining and geology, as well as photonics and calibration transfer. These instruments are commonly used both in academia and in industry, and across a wide range of different applications. Now, the Naturaspec line of instruments primarily targets the needs for climate research, remote sensing, ground validation, forest canopy, plant health, soil nutrients, and mineralogy, as well as many other environmental and remote sensing applications, but it's not limited to that. So here are some examples of our accessories in the field, some pictures of them, and some spectra. Now, I'll start by explaining what spectroscopy is and how a spectrometer works. The electromagnetic spectrum, as emitted or reflected by various materials. The electromagnetic spectrum is a representation of electromagnetic radiation, and it's defined by its wavelength. So a reflectance measurement directly relates to the material or chemical structure and bonds that the light is reflected off of. So our spectrometers typically have a range of 350 to 2500 nanometers. And it essentially operates in ratio format or in direct energy format across that 350 to 2500 nanometer range. So you can think of a spectrometer, or you can think of your eyes like a spectrometer, but its spectral range is only in the visible light. So bandwidths would be like colors. So different chemical structures will have different absorption features at very defined points in the spectrum, and we use that to identify the chemical structure of those materials and then relate them to different sciences. So how does a spectrometer work? Older spectrometer designs typically follow this kind of workflow. So you start on the right here with the light bulb. And that's your signal. And your signal is sent through this field of view. So out the end of a fiber, you typically have a 25-degree field of view, which means your field of view is going to be defined by a distance to a target. Now, that signal is sent through a fiber optic cable. And in the older designs, it will go to a trifurcated cable that will bring indiscriminately 1/3 of the signal to each detector. At that detector, you'll have moving gratings that are both slower and less repeatable than our design. So, and less durable. So when you trifurcate a cable, you're going to be grabbing 1/3 of the fiber cores that are in your fiber and send them to each detector. So there's a silica array that's for your visible light, and then you'll have a SWIR1 detector and a SWIR2 detector arrays. And so you'll trifurcate the cable, which means you'll grab 1/3 of the cores and send it to your visible light, 1/3 to your SWIR1, and 1/3 to your SWIR2. So your grabbing not just the part of the spectrum that's relevant to that detector, but just dividing it into thirds. The other thing that does is it makes your field of view non-uniform. So oftentimes with older spectrometers, there's the necessity for taking more than one sample and averaging them together by rotating your sample 90 degrees or rotating your fiber 90 degrees to account for the fact that the fibers are not uniform. So what sets spectral evolution apart is a fundamental design difference here, where we're decomposing that signal using dichroic beam splitters. So we're able to separate out the visible light and send the visible light to the visible light detector, and so on and so forth with the SWIR1 detector, sending that SWIR1 range to that detector and SWIR2 range to that detector. That way you're not sending visible light at the SWIR1 and just losing that signal altogether. So by doing that, we're able to create an actually uniform field of view with no need for any kind of procedures that make your data more uniform in your field of view. And we also are able to bump up our signal to noise ratio by doing this. So that's why we have significantly higher sensitivity, is due to this fundamental design difference, because we're using the maximum amount of light possible to each detector. Now, moving on to some of the challenges in field spectroscopy, so I can kind of highlight what we were trying to target when designing the Naturaspec Plus. So oftentimes when doing field measurements, you're operating in an uncontrolled environment. So you're constantly monitoring, what are your environmental conditions? Are my conditions changing? Do I need to re-reference? And it's important to understand these things and monitor them while you're in the field. It's often reliability and stability of these measurements are at a premium. So with environmental conditions changing or could change at any moment, it's important to have a fast acquisition time, and it's important to have an instrument that is stable and going to take repeatable measurements. So controlling that field of view, having a uniform field of view, especially in heterogeneous or optically complex conditions, which is oftentimes what we're working with, is incredibly important. So in a field campaign, accessibility, portability, connectivity are all very important. So you're going to be sometimes out in the field in places that are hard to get to. So being portable and easy to connect to your instrument is incredibly important. And making sure when you're trying to set up your instrument in the field that it's as simple as possible so that you can get to collecting that data that is so important. And on the vein of data quality or collection of data, all of our instruments have an auto optimization step that ensure that even in varying conditions, you're constantly optimizing your signal to get the best quality data. We have an optimization step and a dark correction that happens automatically every time you hit scan, with no need to do anything on the user end. This step is made just to ensure that all of the data that you're collecting is going to be as high quality as possible. So further challenges of remote sensing is, one of the most common applications is intercomparison with other sensors and drones and satellites for ground truthing and remote sensing. This is because other sensors are limited by spectral resolution and spatial resolution, and in order to conduct ground truthing and determine what is present at a subpixel level, you have to understand what your field of view is and what kind of spectral resolution you're working with and comparing to. So in situ measurements or ground measurements are incredibly important, because you're going to have the highest quality data on the ground with a defined field of view that you can compare then to the coarser resolution from a drone or a satellite. And so it's even more critical when you're taking field measurements that you understand what field of view you're sampling at, so you can correctly extrapolate that to the coarser resolutions. Another thing to understand is on the left here, we have is understanding what your reference scan is. What light are you using to take a scan? So every light source is going to have a different amount of signal across the spectrum. So it's important to understand that if you're working with, and that might have limitations. So if you're working with sunlight, you're going to have the limitation of the atmospheric absorption water bands at 1300 and 1800 roughly, where you're getting little to no signal through the atmosphere. So when you're working in a ratio, you're not going to have any signal there, so it may look noisy. So in our software, we actually are able to deal with that so that you can get and look at clean data while you're out in the field. It's also important to understand what you're actually scanning. Is it optically complex? Is it reflective? Is there anything in your field of view that may be contributing to your spectrum or your scan? And so that makes it incredibly important to have a defined field of view and a fast acquisition time if things are changing. So our spectrometers have improved greatly, and spectrometers in general and spectroradiometers have improved greatly in recent years. We've improved resolution and sensitivity, and where the Naturaspec Plus really fits in is right where its predecessor, the Naturaspec, fit. So the Naturaspec Plus is going to have the same resolution and sensitivity as the Naturaspec, but it's going to have more, or it has more metadata capabilities, and it's lighter and slimmer for field use, as well as greater integration of a hot swappable battery, as well as an easy to use accessory and tablet called the Sensaprobe, which I'll go into more detail. So the resolution of the Naturaspec Plus is 2.7 in the Viz, 5.5 in SWIR 1, and 5.8 in SWIR 2. So this is the same resolution as the Naturaspec. And like I said, it has a hot swappable internal battery, so there's no need to have extra wires hanging off, although if you do have multiple batteries, you can get up to 6 to 8 hours of field use on those batteries. It's capable of using both with a shoulder strap and in a backpack, so it's very light and compact. It's able, making it much easier to go out in the field, and it's incorporating the metadata of an inclinometer, a distance finder, GPS, solar angle calculations, live field of view, and as well as an advanced field of view calculator that will be using that distance to target to calculate your field of view. So with each measurement, you're going to have a defined field of view. And so here is a short video showing the instrument in the field doing some ground measurements. As you can see, I'm using the shoulder strap, but you can also use a backpack for added comfort. In my hand is what's called the Sensaprobe accessory. That contains all of those extra metadata calculations that I was talking about. And on the back of that Sensaprobe is our new tablet. This will all be sold as the Sensaprobe will be sold as an accessory, and that will give you that live field of view and your scans in real time while you're out in the field. So to reiterate some of those field challenges that we're trying to address is the accessibility and portability out in the field. When you have limited schedule, it's important to have a fast acquisition time, and it's important to be able to function at your best in the field by incorporating internal battery, which will allow you to increase your sampling time without ever disconnecting from your instrument. Wireless connectivity to give you some hands-free use for any note-taking that needs to be done. Auto optimization to make sure that all of your data quality is coming out well. And just simplicity of operation. This is designed to be an easy to use field instrument. And to talk about the field of view, as I was saying, the distance to your target is very important to define what your field of view is. If you're further from the target or varying in your distance to the target, you're going to have varying field of views and sample sizes. And if that isn't properly defined for field measurements, you'll be generalizing many different sizes of samples. So it's very important and a great improvement for data quality and repeatability to be able to know how far you are from the target every time you take a scan. This will be great for field validation as well as repeatability in different kinds of applications. And so with that, the Sensaprobe has all of our lenses integrated so that it will calculate the field of view based on any degree lens that you're using on the Sensaprobe. And it will quickly adjust its calculation using that distance finder and the angle that it will be at. So the Sensaprobe's obviously our newest accessory. It is designed to be ergonomic and easy to use. In one hand, you can operate the instrument, you can take scans, and you can collect all of that metadata, all with a hand free to do whatever you need to do in the field. So this is what our new interface looks like using the Naturaspec Plus. And so as you can see, we have a rangefinder. Up at the top, all of that metadata is recorded. And on the left here, we have a live camera field of view. So this is the view of the camera. It's not a stagnant image. And this black circle is actually drawing on the camera based on how far the target is. So we have the big buttons for ease of operation in the field, the inclinometer on the top right, as well as the rangefinder, system temp, solar angle, volts, and then detector temperatures and internal temperatures in there, so that you can monitor the quality of or the conditions of your instrument while you're out in the field. It also has easy connectivity with all of our different new sensors on it, as well as the instrument. They're simple. It's just one button to connect to each, and you can reset them with one button as well. So getting started in the field is a quick and easy operation to optimize how much sampling time you're going to have. So we also have the same kind of optimizations and customizations that you can do with all of our other instruments. We have the optic selections, so you can have radiometrically calibrated lenses and diffusers, and you can select what kind of averaging you're going to do for your field procedures. There's also the auto integration, which is that optimization step that is optional, but I recommend keeping it on for most applications. And then reflectance calibrations can be loaded in here as well. You can also customize how you want your data to be represented while you're looking at it in the field or back in the lab. And all of our data is exported as an ASCII file, so it's easy to work with. and you can turn on and off those water bands that will create noise. So we also have the added utility of timed target and reference scans. So you can define different operations for holding down your trigger button for different amounts of time. So a long hold on the trigger will take a reference scan, and then you can just click a short press of the button to take target scans. So you can operate it without even touching the tablet. You can take a reference scan and a target scan all with one hand. And so the Naturaspec Plus is also going to be compatible with all of our previous accessories. So it's integrated with the contact probe. So here we have a contact probe where you'd be using your own internal light source in the contact probe. So in there's a tungsten halogen light source, and we have a 10 millimeter spot size and a 3 millimeter spot size. And the contact probe has a sapphire lens to ensure that it's non-scratch. You can put it directly onto a outcrop, a rock, or anything, and you're not going to damage the contact probe at all, and it won't contribute to your signal. And so that's a great way to eliminate any field conditions, is to use a contact probe, because your signal will always be the same or be consistent, and you won't have to worry about any changing conditions out in the field. We also have our leaf clip. This is can be integrated on the Naturaspec Plus as well as our new pine needle adapter. And so this will let you get scans of any kinds of materials that may be sensitive, like vegetation. So we have our light source integrated into the handles so that it doesn't send any of the thermal signal that may dry out a leaf or manipulate a sample in any way. So this is great for repeatability and characterizing things that are in your ground truthing and speciation and vegetation health. This is a great accessory to go along with the Naturaspec Plus's different utilities. And then we have the benchtop probe, which is designed for lab measurements and loose materials. If you wanted to scan soils and vegetation out in the field and then collect a soil sample for more scanning back in the lab, this is a great tool. You fill these puck trays. They have the sapphire lens as well. And it has a high-powered light inside of it to make sure you have great signal in the lab for lab measurements after you get out of the field. So this is a great accessory to the Naturaspec Plus as well. And it just connects to the fiber in the same way. And as I iterated earlier, we have several different lenses that can be used to accompany the Sensaprobe. We have a 1, 2, 3, 4, 5, 8, and 10 degree lenses. And then the bare fiber has a 25-degree field of view. And so by doing that, you can ensure that when you're sampling things that are far away or closer, you can manipulate that field of view and make sure that you're sampling at an area that is relevant to your study. And then we have diffusers that give you a 180-degree field of view and work the same way as the lenses. And all of these lenses and diffusers can be radiometrically calibrated as well. And then here we have a Gershon tube for like 1-degree field of view measurements and measurements of energy sources. And so remote sensing, in conclusion, remote sensing is a diverse field which requires a versatile instrument. And the Naturaspec Plus fills that versatile instrument role. It has an incredibly high sensitivity and spectral resolution. Fundamentally, Spectral Evolution's emphasis on resolution and signal-to-noise ratio and not sacrificing signal-to-noise ratio makes it one of the most compelling instruments of our time. And This instrument, along with the Sensaprobe, is ideal for nearly any kind of field reflectance spectroscopy or remote sensing that you may be doing, and most applications require some amount of field collection. So thank you very much. I was happy to introduce the Naturaspec Plus, and I look forward to answering any questions that you may have about it. Thank you.